Hello, all my Fusion fanatics out there. This is Brad Tallis from Autodesk. It's been a while. I was just realizing between Autodesk University, visiting some customers, and Thanksgiving, and other people doing live streams, I haven't been on in a long time. So I appreciate seeing all the comments. Everybody out there is really nice, so I do appreciate that. Speaking of Autodesk University, I wanted to start out by saying that all of the classes are now online. So if you were not able to attend Autodesk University, there is, in fact, it looks like there's over 90 just Fusion classes. I filtered it just for Fusion. There's hundreds and hundreds of classes out here. For example, robotics design in Fusion 360 and, Fusion team data management, etc. I put the link out in the description of this live stream, so please feel free to go out there. You can filter it for certain things. For example, if you just want to learn about generative design or simulation or additive manufacturing, etc. You can filter with this list. So great classes out here. In fact, one of them is so good that I'm actually going to use it in today's presentation. This was actually a class that Ben Weiss and Chris Wade did with Starling Cycles. So I'm actually going to kind of go through their notes here pretty quick. Their slides. I personally recommend watching this from that Autodesk University link. But I wanted to share this because there is such good information in here. Going from how they generated a part, how they edited the part, and how they made the part. And that's actually what we're going to be talking about in today's live stream. Now, this is what a lot of people think about when we talk about generative design. All these, impossible to manufacture parts. Well, and I thought this was pretty funny. That's wrong on all levels out there, right? So you can have different methods for manufacturing your part. So for example, 3-axis, 5-axis milling, or you can do 2 or 2.5-axis milling. And this is, again, this slide deck is awesome. This is probably my favorite slide in here. It's showing, manufacturing with the 3-axis milling versus the 2.5-axis milling. And you'll notice that the 2.5-axis milling is kind of slow to start out, but watch what's going on here. In just a matter of moments, they're able to manufacture from start to finish using 2.5-axis milling. And yeah, they're done. And over here, we're still, smoothing off those swoopy surfaces or whatever. A lot of people think this is, over on the left, what generative design is. But we're seeing a lot more customers using our new functionality of being able to do 2.5-axis or 2-axis milling, for example. So again, I want to say thank you to Starling Cycles. This is their example that they used. And what's kind of cool is they previously welded 12 separate parts together. And by using Fusion 360's generative design, they're able to reduce that workflow. So you're going to see the original and the new one. And we're going to talk about, you might look at this and say, well, that wasn't generatively designed. Well, actually it was. And this is what we're going to focus on today is how did we go from here to down here, okay? And so here was their original swing arm design. It has the shock and all that kind of stuff. So this is the part we're going to be focusing on. And what they ended up doing was they kept particular regions. And this is what Matt LeMay showed in last week's live stream where we were talking about preserve regions and keep out regions. So you can kind of see these circular items and where it connects to the arms are the preserved. We don't want to change that at all. Okay? And then I'll get back to that here in a second. A quick reminder that what we're showing today, you can actually work with. We're doing free generative design until the beginning of the year, so through December 31st. You can learn more right here, so autodesk.com free generative design. We want to thank Amazon Web Services and NVIDIA for sponsoring this. It's really cool to see what some of the people are doing with generative design. Here's, oops, wrong one here. Let me go to this really quick. Here's a prime example I wanted to show earlier. Check out this staircase that was generatively designed. I think this thing is incredible. Now, a lot of you might say, well, that's kind of weird or whatever. I would love to have this in my house, but look what people are doing with generative design. They're kind of thinking outside the box. Okay, so coming back to this slide deck, here's the generative result, okay? And you'll notice it was actually kind of generated in layers. There's 3 different layers here. And so when generative was complete, it actually created these features. In fact, you can kind of see the layers right here. So there's the sketch, then there's the extrude, another sketch, another extrude, etc. And then they were combined together. So this is what Fusion 360's generative design came up with. Okay, well then you might come in and say, okay, that's cool. That's a good starting point, but I want to kind of tweak it. And this is really what I think is so cool about the generative design. Yeah, I might have come up with something like this, but generative started and did all the heavy lifting for me at the beginning. And now I have something I can work with and make it manufacturable. So obviously this part can be manufactured. It does not have to have a 5-axis CNC machine or a metal sintering 3D printer or whatever. I can do this on my CNC machine in the garage, right? So one of the things we want to think about is how we need to consider how this part might be machined. Okay, so here's our kind of our finished product. And so obviously it has kind of a top side and it has a bottom side that needs to be, some features need to be manufactured, etc. So we need to think about how can this be manufactured. And I love these slides because it kind of makes you, again, think of what's the best methods here. So for example, you could use these, hold down clamps or these block clamps, right? Or you could hold the device, hold the part in a vise like this and machine away the material and then maybe flip it over to finish the next side. And that's kind of what you'll see here in just a minute. We need to consider about what kind of tools do we have, how long are the flutes, etc. Are we going to be able to actually manufacture this with the tools that we have in our shop? I'm going to show a live version of this. This is some new functionality in Fusion 360 where you can analyze a minimum radius. So it actually allows you to type in, for example, what your maximum tool radius and your minimum tool radius is. In this case, I wanted to use a 10 millimeter cutting tool. And it's showing me that it wouldn't be able to get into these tight corners. But if I were to use a 5 millimeter cutting tool, it would allow me to get into most of these regions. But then I can see, for example, there's a couple regions that I would not be able to get into. So I might have to do a different machining process to remove that pocket, for example. And again, I'll show this live. This is another cool example of how is this part going to be manufactured. So there's 3 different methods they're showing right here. First method is using these hold down clamps. So we put our material in there and we machine a majority of it away, but obviously we can't machine all of it away because of the clamps. Then we move the clamps and come back and do some finishing machining. Okay, so you can kind of see what the tool path would look like in this example. Method 2, again, using the hold down clamps, but making sure that they're in regions that aren't going to get hit by the cutter. So you can kind of see we're machining the top side of the part in this example. And then we flip that whole thing over to the bottom side, put some clamps back on there, and machine the other regions, leaving some tabs that we could come back and remove later, for example, as you can kind of see here. And then the third method would be to put the material in a vise, for example, making sure that there's enough clamping room, cutting the majority of the part out, But you'll notice in this interior region, we've created some holes that we can then flip over and bolt this to a fixture. And then come back and do the finishing machining passes on the other side. And then you can kind of see how we could remove all that extra material. So again, we need to think about how are we going to first generate the object. Are we going to be able to edit the object? And then how would we make the object? And so that's what I'm going to be showing today. And this is a really cool example. The generate took around anywhere from 3 hours to overnight, depending on how many simulations you run. Took them about 2 hours to make the edits to the model. And then manufacturing for the cam was about 2 hours, and the machining was about an hour. So they were able to, in about 1 day, go from an idea to a part in their hand using generative design. Okay. So let's kind of continue from where we left off last week. Matt LeMay did a wonderful live stream talking about what is generative design, how do you set up a generative design and run the simulations. I'm going to use that example in this live stream. So I'm using this motorcycle triple clamp. So just to kind of do a quick review, you can see some green and some red parts. So the green parts, these are my preserved geometries. This is what I want to keep, okay? I don't want generative to kind of go inside these holes. I don't want them to go outside too much. I want to keep these specific sizes. Then we also have the obstacle geometry, which is these red parts. I don't want generative to go into these red parts either. So you can kind of see it's going to keep everything in this particular region, in this particular area. We set our objectives of minimizing our mass, making sure we have at least a safety factor of 2. We specified different kinds of manufacturing methods. So in this case, we're going to do 2.5 axis, 3 axis, and 5 axis machining. You can kind of see the tool direction. We specified our tool direction, and we were even able to specify our minimum tool diameter to kind of keep from getting little tiny regions, for example. I also turned on 2-axis cutting. So here's my 2.5 axis. Down here I can say 2 axis, and I only want to cut in the Y direction. So what's the difference between 2.5 and 2? Well, 2.5 axis allows you to cut on one side of the part, and then you would flip that part over to machine the other side. With 2 axis, we are only coming in from one direction and cutting, and we're not flipping the part over. And you'll see the examples of that here in just a moment. We also picked which kind of materials we were going to make this out of, and you can see different kinds of aluminum, titanium, Inconel, different kinds of aluminum, and stainless steel. So we picked our different materials, and then we set up our loads and constraints. So you can kind of see we've got torsion, tension, compression, etc. And again, this is just kind of review from what happened last week. Okay, so once we set all that up, we did a quick preview, and then we generated our generative design part. So now I'm going to go into exploring. Okay, so what this is going to do is show all of the different results that we came up with. It takes a little bit for it to do the preview, but you can kind of see here all of these cool designs as I scroll through. And these are from the different results that we asked for, different materials, different machining methods, etc. Okay, there's a lot of information in here, and this is what the slide was talking about from 8 hours to overnight. It kind of depends on how many simulations you run. Now, what I really like is over here we have these outcome filters. Okay, and what this allows us to do is to isolate. So, for example, I'm going to scroll down here, and we can see manufacturing method. So unrestricted, this kind of gives you, this organic type shape or whatever. But then you can see we got 2 axis, 2.5, 3, and 5. And for example, I could come in here and just isolate, just to show me the parts that can only be cut with 2 axis cutting. And so you can see it's filtered all of the other stuff out, and here are my results for the 2 axis cutting. I could also do the same thing for the 2.5 axis. So now you can see I get more results for the 2.5 axis milling. And some of these are kind of cool looking. Some of them are a little bit more blocky than others. Some of them have, you can kind of see the thin arms between the posts, etc. Okay, and then let's take a look at one of these. So for example, maybe this guy here. I'm going to go ahead and click on it, and it allows me to visually see what the results are. So I can kind of rotate around, taking a look at it. You can kind of see it sort of machined some areas out, some pockets a little bit deeper than others. I see a couple little tooth marks or whatever you want to call them there. But this is a prime example. We can see that this is a 2.5 axis result. So we can see the orientation is in the positive Y and in the negative Y. And so you can kind of see we would machine in the positive Y, then we'd have to flip the part over and machine it from this direction also. So that's what a 2.5 axis result is. Now I kind of pointed over here, there's a lot of information. For example, manufacturing method, 2.5 axis. Estimated cost. We're going to talk about this here in a little bit. What's the mass in pounds, for example? What's our safety factor, etc. Okay. Now I have a lot of results here. I'm going to go ahead and click on this properties view, and this allows me to see all of the results, or I should say all the properties of these results. And this is kind of handy too, because I can see, sure enough, positive and negative, 2.5 axis, 2.5 axis. So we can see all of these are 2.5 axis milling. If I were to turn those guys on, we can see we got 2 axis, 2.5. So I'm seeing all of my results here. Okay. Let me go back to the 2.5 axis. I'm going to keep going across the top here. We got this scatter plot view, and you can see here I've got a bunch of results. In fact, let me just do all of these, and you'll see all of the different results that came up. And we call this a scatter plot. And you can kind of see across the bottom, it's showing me the mass in pounds. So anything from just over a pound all the way up to 5 pounds. And then we can see over here on the left our minimum factor of safety. And what's neat about this is I can hover over any of these dots and it's going to show me the results. So I can see this one here. This one's going to require some complicated manufacturing methods, but it does, meet a pretty low weight, and it's a little bit low on the minimum safety factor. Where this one here looks like it could be manufactured with 2.5 axis milling. Okay. Now you'll also see across the bottom all of the different materials. So for example, the blue dots are made out of aluminum, the 6061, whereas the dark ones here are made out of titanium. The Inconel are basically in this area right here, and then we can see the stainless steel kind of weighs the most, and maybe I want to keep this part as light as possible. In fact, I'm curious mostly about the parts that are less than 2 pounds. So I'm just going to draw a selection window till I get to about the 2, and now I'm looking at just the results that are less than 2 pounds. Okay. And maybe I'm not as concerned about the minimum factor of safety as I am about the cost. So I might come in here and say, you know what, what's the estimated manufacturing cost? And this is really kind of cool. So you can kind of see we get this plot, the scatter plot with these lines, and it's showing the estimated cost for each of these manufacturing processes. So I can see down here, Obviously, the aluminum looks like it's going to be the cheapest method to manufacture. I can see if I were to go into this region here, I have a lot more variability on how much it's going to cost because of the material, how complicated the part is, etc. Okay. Okay, let's zoom up maybe on just this region down here. So I'm going to just kind of zoom up like so. And if I click on one of these guys, it gives me the information. It's showing me the result in this menu right here. And this is fairly new. This is actually a really cool icon right here. And it allows, this is actually using machine learning. So it's going out and trying to find similar results. So I've only clicked on one. And when I click on this little icon, it's going to go through and find parts that are very similar. And when I click on this result, it'll bring up this page here. I think this is really neat. The fact that I picked on one of them and it went out and found other ones. In fact, you'll see, like, for example, the arm is kind of thicker up here, but in this result it's thinner here, but the overall shape is about the same. And same thing over here. It's found, you know, you can kind of see the shape here. You can kind of see this is more of a solid shape. This is a different material down here, but it allows me to kind of quickly visualize, okay, this is the one that I liked, but maybe if I'm making it out of this material, I can use thinner walls. Maybe this is what I want to use instead. So really cool functionality. So let me go ahead and do that again. I'll pick, let's see if I can pick a different one here. Let's see if any of these have, and if they don't have anything similar, it won't show that icon. In fact, let me go to, let me go ahead and I'll just leave it like that. I don't think I want to change. I'll reset the zoom. Let's just take a look at some of these guys. So I'll click on this one here. I'll click on the similar icon. So this is more of the complex manufacturing, but you can kind of see here are the results. And I'll kind of look at it from the top. So notice this one has a couple little tiny little extra things here where this only has one, but they look very similar in results. You know, this one doesn't have any of them, but I just am blown away that we're using machine learning to help speed up our design processes. Okay. Cool. Okay, so let's go ahead. I'm going to zoom back up on, well, I'll just do maybe right here. And I'm going to, again, filter. I just want to see the 2.5 and the 2-axis manufacturing. Okay, so this one here, I'm going to go ahead and click on it, get my preview. I think I clicked on this earlier. This is the one I was kind of showing. It has the top and bottom pockets, for example. Maybe this is the one that I'm mostly interested in. Actually, I lied. Let me back up. I'm sorry. I wanted to show one more cool functionality with this. Let me select, oops, sorry. I'm going to go back to the scatter plot, and let's set this back to minimum factor of safety. And I'll click on, let's just say, for example, this guy here. Let me see. Yeah, let's do all of these real quick. I forgot to show these icons across the top. So this is the one where it found very similar items. And we have a couple different options up here. So here's the model view. Then we also have the stress view. This shows how much stress is on the model. I kind of wish I had this option with my wife every once in a while so I could see how stressed out she is at me. I'll wait until Autodesk adds that. But anyways, we can kind of see how it's showing different stresses in different areas. We can kind of see this one here, maybe because the arms are a little bit thinner, it's getting a little bit higher stress in that region. I can also pick on seeing where my original keep outs, you know, my preserves, all that kind of stuff. But anyways, I like to show the stress view and the resulting view. Okay, so with that, I'm going to go back. Let's just pick on this one here, so you can kind of see it. It actually automatically selected all 4 of them for me. I'm just going to keep one of these, so let me turn those guys off. This is the one I've finally decided, after looking at how much it's going to cost, how much it's going to weigh, my safety factor, meets 2 in this case. I think this will be pretty easy to manufacture. This is the one I've decided to pick. So across the top, you can see we have this create new design from outcome. And I've already done this because it takes a little while to export it out. But you just click on this icon, and after a while it comes back and it says the design is ready. Click to continue. So I'm going to push this into Fusion 360. Okay. And here it is. So as I'm taking a look at this, notice this is an actual model. And we can even see, for example, we can kind of see where the layers were created. But take a look at the timeline. So we can see here, for example, here's our preserves. Here's our obstacles. So it actually brought those across for us. Okay. Then there's a sketch. And if I edit this sketch, you can actually see the spline that was created to create that particular shape. So it did all of this for me automatically. Now, again, we need to think about how are we going to manufacture this part. In this example, you saw a whole bunch of little splines, lots of little dots. Maybe I use this to kind of just trace over it and recreate the model myself. So I'm using the generative design kind of as a base or a foundation, and then I'm designing the part off of that. Or we can leave the generative the way it was, maybe tweak it just a little bit, change some things, and then have it manufactured. And that's what I'm going to show in this example. So I'm going to leave these sketches alone for now. But there's some things on here that I don't like. So for example, I want to fix all of these regions here. So I'm going to just come in here and say delete, maybe just draw a box around all of that stuff, and maybe select these 2 faces and say OK. And you can see that I kind of removed those extra little layers. Looks like there's a little tiny face here. I might just click on it, hit the delete key on my keyboard, and literally in a matter of seconds, I've now have a nice smooth representation that I could manufacture. So instead of having to edit the sketches, the multiple sketches, I was able to just come in and delete some faces. Okay. And this is kind of what was being shown in that slide deck, where it comes in multiple layers and then gets combined together, but then you can come in and make some design changes. I could even come in here and say, you know what, I want to put my logo on here, or maybe I want to create a sketch and add, some circular shapes in here, some circular recesses or whatever. I could go ahead, because this is an actual model, I could come in here and make changes to this model, right? So I'll just come in here and push down. You can kind of see I could create those recesses if I wanted to. So again, kind of using the generative design as a starting point, I can then tweak this design the way I want. Okay. I could also, I mentioned this earlier, I could come in and, for example, create a whole new sketch. So I'm going to just say create sketch and use the spline tool. And I could just come in and maybe grab a couple of these points. And then all I want to do is kind of get close. I'm not going to be too exact. Oops, need to be more exact than that. You can kind of see how I can click on these and just trace around the model. So, and I'm just going to do really fast just so I can get through this. So I'm kind of using this as the base design. And then maybe I would project the important stuff. So for example, I want to project these circles, the pockets, like so. Say OK. And then I'm going to go ahead and delete the underline shapes. I don't need this anymore. I just want the basic shape, right? So I was able to kind of clean this up and get it looking really nice. Let me get rid of that guy. Maybe get rid of, yeah, there we go. Get rid of that guy. Okay. Then what I can do is use that profile and extrude this. I'm going to create it as a new body, obviously, but I'm going to start to drag down. I'll pick this bottom face. I'll say this is a new body. Looks like I missed a little area here, but you can kind of see what that looks like. Let me turn off the original body, and here's my nice new smooth design, right? With nice tangent surfaces, etc. And I just ended up using this base model. You can see I was pretty close. I'll go ahead and turn my sketches back on. I'll turn this guy back on. And now I could come in and extrude these regions. How far? I'll just turn on my existing model and snap to that face. So I would basically probe through and snap to that face. So in this case, it's minus 1.6 centimeters. I'll say OK. And now you can see my finished product, for example. And again, I could come in and tweak with this and change it or whatever. So many different manufacturing methods for you to use. I'm going to stick with this one here, the one that's double-sided. Okay, I see lots of questions. Hopefully Aaron's able to answer those. So, okay, let me continue on here. So let's say this is the design I want to manufacture now. So I'm going to switch into my manufacture workspace. And we're going to basically figure out how are we going to add the tool paths to this. So obviously we have to start with a setup. So I'm going to go ahead and click on setup. Now you'll notice that my Z direction is pointing in the wrong direction. So I'm going to come over here and specify select Z axis or plane and the X axis. So by doing that, I can click on, for example, this face right here, and you'll see that it pushes the Z axis to be up and down. I could also flip the X axis if I want to. In this case, I'm going to kind of call this the front. And then finally, I might touch off on this top left corner of my material. Okay, now I've decided I'm going to hold my part in a vise. That's how I'm going to manufacture this part. So I'm going to go over to my stock tab, and I want to add some material to the stock bottom. So let's just say maybe like 1/2 of an inch, and you can see now my part is kind of near the top, and we've added some extra material at the bottom to be held into a vise. So that was the stock bottom offset. I also have looks like 4/1000 across the top that I'm going to remove in a facing operation. So I'm going to go ahead and just say OK. And I now have my stock setup. So like I mentioned, I'm going to do a facing operation. So I'll come in here and say face. With manufacturing, we go left to right. So the very first thing is select a tool. So I'm going to come in here and let me just do, I'm just going to do like a 2-inch face mill. And that's all I'm going to do. I'm just going to say that's the tool I want. I'll say OK. And Fusion will figure out how do I need to go back and forth. I could go in and change, the ramping and how many passes and all that kind of stuff, but I like to leave things default. I also like to come in here and simulate each tool path once it's complete. That way I can kind of see what is it going to do. So I can kind of see as it's going along, it's removing just a little tiny bit of material in a couple different passes. You can actually see the 3D model underneath. Okay, so there's our facing operation. Okay. Now what would be the next thing? Well, I'm going to remove a majority of the holes here. So I'm going to use, I really like using 2D adaptive. This is an incredible methodology to use because it figures out the best tool path to remove a large amount of material using a majority of the cutter. So instead of going down 1/8 of an inch and machining around in circles and then coming down another 1/8 of an inch, where I'm only using about 1/8 of my cutter, or 1/8 inch of my cutter, it's going to allow me to machine much more material, which with a lot more of the cutter itself. And so you'll see that here. Let me go into my tool. I'm going to use, let's use maybe like a, I don't know, a 3/8 flat. Let's go ahead and use that guy. And then I can specify which region. So I'm going to select that region, and this region right here. I'm just going to go ahead and say OK. Now, I don't know if you've watched any of the live streams with Angelo. He's one of our CAM specialists. He has a lot more manufacturing experience than I do. In fact, he should be the one doing this live stream, but he has some really cool tips and tricks. And one of the ones he showed is when you're plunging deep, you want to add a little bit of a taper to the ramp. So let me come in here. I'm sorry, not to the ramp, but to the plunge. So I'm going to go into my linking, and actually it is in the ramp. I'll come in here and say ramp taper angle. You'll see it's set to 0. I'm going to just make that maybe like 2 degrees, for example, and say OK. And what that's going to do is you can kind of see how it tapers that down. And that allows chips to be able to come out as it's being machined. So again, it helps with the cutting, it helps with the finish, and it helps with not creating as much wear on my cutter. Another thing I might do is, I do like adaptive clearing, but that's a pretty deep cut to do. So I might come in here and say, you know what, I want to do multiple depths. And let's just go down maybe 1/2 an inch. So I'm going to say 0.5 in this case. And watch what happens when I say OK. It's going to recalculate my toolpath, but now you can see that it's doing it about 3 or 4 step down. So it's going to come down, machine this away, come down again, machine that away. And you can see the tapers on each of those levels. Okay, now here is why I personally recommend simulating. So I'm going to come in here and say simulate. I don't need to simulate the face. I'm just going to go ahead and do this guy, and so I can see how is it going to cut this material. And let me change my colorization. I'm just going to do a comparison here. Now you can kind of see it's cutting down, then it's coming over, and so you'll notice that it only did a certain depth, then it's coming over to this hole here, going to a certain depth, and then it's going to go over to this third hole and cut. And maybe that's what I want, but maybe it's not what I want. I would much rather it do the whole hole all at once and then go to the next one. And I wouldn't have known this if I hadn't done the preview. So every time I kind of make a change in my toolpath, I like to run a quick preview just to see what's going to happen. Okay, so I want it to cut all the way down to the bottom and then go to the next one. So I'm going to edit my 2D adaptive. I'll go into my passes. Again, you can see it's doing multiple depths. And there's an option here called order by area. And so what that means is it's going to finish that one area first and then go to the next area and then go to the next area. Okay, so that's what order by area is. Another thing that I like to do is this is machining just to the bottom of my part. Now remember, we're going to have to flip this part over and then machine the extra 1/2 inch off. Well, I want to make sure maybe that the hole goes just a little bit farther than just the bottom of the part. That way there's no sliver faces that are left when we machine that. So I might come into my heights tab and I'm going to specify my bottom height. Okay, so I'm going to come in here and say maybe I want to go minus 5 thousandths or something like that. So when I say OK, it's going to recalculate those tool paths for me. Let me see. Maybe I went the wrong direction. I did. Edit. Passes. sorry, heights. Let me make that a positive and see what that does. Okay, maybe not far enough. Let me fix that. And I'm going to say from the model bottom, there we go. And let's try the minus, see if that helps. Okay. So now let's preview that guy. And we should see, I'm going to speed it up a little bit. We should see that it plunges all the way down this one hole. So there it goes to the next level, going around, goes down to the third level, goes around, and then obviously continues on to the next hole once that's complete. The other thing hopefully you all know about is this green bar at the bottom. If you see any red in here, that means there's an error. For example, maybe the holder is going to collide with the stock, or the tool isn't long enough or whatever, but I can see that this is nice and green, so it's going to complete the way we want it to complete. So there we go. Okay, moving on here. So I've basically machined these out. Another option that I like to keep on is stock to leave. Okay, so what this is doing is it's leaving just a little bit of material that I can come back and do a finishing pass. Now in this case, I don't want to leave any axial, so I'm going to change this to 0, and this might be why I wasn't seeing the toolpath come out the bottom. There we go, you can kind of see that there. So it's going to leave a little bit of stock to leave, and then I'm going to come back and do a finishing pass. So what I'm going to do is right click on my 2D adaptive, and I'm going to create a derived operation. And this is a really powerful command. What this allows you to do is say, use all of the information, the cutter, my feeds and speeds, my profiles, etc. Use what I've already set up in this tool to happen in this tool. So for example, I'm going to come in and do a 2D contour. Now you'll notice it's using my 3/8 flat. If I came into my geometry, it remembered my geometry that I did. It remembered my heights. So I didn't have to enter all this stuff in again. And in this case, I don't want to do multiple depths, so I'm going to turn that off. And maybe I want multiple finishing passes. So instead of just one, I'm going to have it do one where it cuts a lot of the material, and then it's going to come back and do a nice finishing pass. So I'm going to say, let's do 2 finishing passes. Okay. I'll say okay there, and you'll see I get these 2 tool paths. So now it's going to hog all that material out, then it's going to come back and just get a little bit of the wall off, and then it's going to come back one more and do a really nice smoothing pass for that. Okay, hopefully this is making sense. So I'm going to come in here and say I want to start cutting these pockets. So again, I'll use a 2D adaptive. So I'll say 2D adaptive. Now here is where this inspect comes in really handy. So you'll notice I'm using a 3/8 inch flat end mill. So I'm going to come in here, and under the inspect, we have this option that says minimum radius analysis. So I'm going to go ahead and click on that guy. And it's asking for the body. So I'm going to go ahead and click on the body. And we can see that if I rotate this around, there's a couple red areas. And again, it might be how, this might not be a really smooth surface or whatever. But I could say, you know what, my maximum that I want to check for is, let's just say maybe 1/2 inch or something like that. Okay. And then I want to do a minimum of, let's just try 0.375. And when I do the 375, I can actually see it highlighting these faces. So using a 0.375 cutter, I won't be able to get into those regions. So maybe I would use a 1/4 inch cutter, oops, 1/4 inch, And there we can see it gets a majority of them. So I can kind of see there's just a couple little tiny regions, and maybe that's okay. Again, I probably would have spent the time coming in and cleaning these little pockets up to make sure I got like tangent edges or whatever. But this is a really cool method to see, could I use, a 1/2-inch cutter to cut these things? And you can see, sure enough, I would not be able to. Okay. But I can use a 1/4-inch cutter. And it even tells you what the optimal minimum radius is, for example. So cool tip right there, using the minimum radius analysis. Okay, so now I can come in and say, well, I'm going to do a 2D adaptive. And I'm going to select a smaller tool. So let me use my 1/4-inch flat for this, because I just analyzed and saw that I should use a 1/4-inch. I'll pick my geometry of these regions here. And again, I'll just say OK and see what results we get. So we can kind of see it's kind of ramp down and then kind of machine using the adaptive clearing methodology to remove those pockets. And like I did previously, I might come in here and add a 2-degree taper for that. I'll say OK. And we can see how it's kind of tapering down. Just like before, it's going to leave some material, and I can show that if I say simulate. I can actually, instead of hitting play, I can hit this. Actually, I lied. Let me do simulate from here. So it's going to do all of the operations. So I'm going to say simulate from here, and now we can see it's broken down. There's a green region and then a couple gray regions. So those are each of the steps that we're doing. So if I click on this, it's now done with the facing operation. If I click on that, it's now done with the 2D adaptive operation. And then if I hit play, you'll see that it's going to come in and do the clearing operation. See how it went from blue to green? And that's because I'm doing the colorization of comparison. So it's actually showing, once it machines all that stuff away, it'll turn green. So you can kind of see now we're actually looking at the physical body. Okay, I apologize, it's running really slow because I'm sharing my screen. And then here I'm going through and I'm just going to advance forward. We can see that these pockets are not green, and that's because there is just a little bit of extra material left. You can kind of see that right here. So again, I really like the preview. It helps me visualize what's going on as this part's being machined. So I'll do the exact same thing. I'll edit this. We'll go ahead and create a derived operation, and I'll do a 2D contour. Okay, so it's using the same tool, geometry, it's using the same pocket selection, passes. You'll notice that it's no longer leaving stock to leave. However, because it's a contour, it's only going to go around this outside. I also want it to machine the bottom, so I'm going to come in here and let's just do maybe like 4 roughing passes. And so you'll see what will happen. So instead of just going around the outside, you can see that it's going to come in here and machine the bottom, and then it's going to come in and do 2 finishing passes. So again, lots of options to set here. You have to think about how are you going to manufacture this part, what kind of surface finish do you want, etc. Okay. And then finally, I would come in and have to machine the outside. So I would probably use a 2D adaptive for this. Okay. I'll use my larger tool. Let's do the 3/8 inch. Since I'm cutting a lot of material here. I'm going to do the stock contour because I want to remove the stock. And then I'll select that bottom pocket, and it always gets me when I do this. There we go. I'll say OK. And it's going to create the adaptive toolpath, I hope. I have an error message or a warning, empty toolpath. So let me This is what happens when you rush. So let me go ahead and do my geometry again. Try flipping to the other side. Is that going to give me what I want? Nope. I need to do the... So notice I flipped to the inside, so it's selecting that, which is obviously not what I want. So I'm going to edit that again, do the outside, say OK. And I don't know why it's not doing my outside. That is really odd. And I'm running out of time, so let me see if I'm missing anything. Pocket selection, that's correct. Say OK. There we go. Sorry, I guess I clicked the wrong thing. So here you can see, so I just basically, I think it was thinking that the stock contour was the actual part. I wanted the stock contour to be the outside of the model. So here you can see it's using adaptive clearing to machine all of that away. Again, I probably would come in and do multiple passes. I'll do the 0.5 in this case, say OK, and then do a finishing pass once it's all said and done. So it'll come back and remove that extra little bit of material. Okay. Now, what about the other side? So you can see that we've got pockets on the other side, and this is that 2.5D that we were talking about. Well, we make it really simple in the Fusion 360 manufacturing. I want to use basically a lot of the stuff that I've already done, so I'm going to come in here and duplicate my setup. So you're going to see I went from setup 1. Now I have another duplicate copy of that. Now what this allows me to do is I could come in and specify my Z direction. So I'm going to say my Z direction is pointing up. I could flip my my x-axis if I want to, like so. Now you'll notice again it's using what I did previously. I actually need to tell it that there's extra material at the top because there's 1/2 inch of material up here. So I'm going to go to my stock, and my stock top I'm going to say is 0.5, and my stock bottom is now 0. So you can kind of think, you know, we faced this off, we machined a majority of it away, but we had this 1/2 inch that was being held in the vise. Well, now we're flipping it over, and again, depending on how you're going to manufacture this, maybe you create some soft jaws that are going to hold this. Maybe you create a fixture that holds this. Maybe you're using Mighty Bite clamps or something that kind of grip onto this. Again, it depends on how you think you're going to manufacture this. I'm going to just say I'm flipping it over and we're going to use soft jaws. I'm not going to show the soft jaws in this case, but that's how we're going to manufacture this. I'll go ahead and say OK. Now you'll see all of these are errored out. So I'm just going to come in here and generate, and it's going to recalculate all of those tool paths. So now you'll notice I have a facing operation in the correct direction. Now I don't want it to cut 1/2 inch, so I might come in here and change my facing operation to do multiple depths. And because I'm using a fairly large cutter here, I might just set to like 1/8 inch. I'll say OK, and you'll see that it's going to come back and forth and machine away that 1/2 inch of material using my facing tool. Okay. And I don't need some of these other tool paths. So for example, I don't need this one because it's already been created. So I could delete this guy. I don't need the contour because it's already been done from the other direction, right? I do want to keep the 2D adaptive. So let's go ahead and edit this. It's using the same tool. The only thing I need to change is the geometry. You'll notice the geometry is incorrect. So I'm just going to come in here and say I want that pocket and that pocket. We'll say OK, and it's going to calculate the tool path using all of the same settings. You can see my taper angle, etc. And then I don't need, well, actually I do want this contour, so we'll do that guy. Same thing with the geometry. I'll just reselect the contours that I want. And maybe we'll do roughing passes. I'll say okay. It's going to come in and cut those pockets. And I don't need the adaptive. I'll say delete. There we go. So I now have two operations, two setups. So the one setup that's going to cut the top of the part and a majority of the outside of it. Then we flip it over. We do the facing operation. We cut the pockets. And then we come in and do a finishing for those pockets. Okay, I know that was pretty fast-paced, but just showing you how you could bring a generative design model into manufacturing and cut it out. Again, a lot of people think that generative design is those really crazy bird bone looking type designs, and the fact that we have added in that 2.5 and that 2-axis modeling technique into generative design really, I think, opens up a huge amount of opportunities for kind of changing how you might design a part in the future. The last thing I'm going to show is modifying one of the more swoopy type meshes. So this is another one of the results that I brought in, and notice the timeline. So it has my preserves, it has my obstacles, and then you'll notice that it has this organic form. So I'm going to come in here and say edit. And now we're in T-splines. So these are all T-splines. And the thing that just blows me away is you'll notice that some of these are frozen. That way you can't modify how they attach to the preserves. But I can modify any of this stuff. And I wanted to highlight a couple key things in here. So in this example, I think it looks pretty cool, but these are pretty small little arms right here, and I don't really think that they're that necessary. Maybe I want to remove them. Maybe I just thicken this other arm over here somehow. Yeah, like Aaron mentioned, this one's pretty close to symmetric, so I could probably work on half of it and flip it over to the other side. But I wanted to show you some neat functionality that we've added to T-splines. So I'm going to go ahead and click on just this one face, right mouse click, I'll say edit form. So I've only selected one face. Right here under selection options, I'm going to expand this open. You can see that we have a lot of options in here, and this one blows me away. Feature selection. I'm going to click on that, and notice it figured out automatically that that was a strut. And so it selected all of those faces for me. Then I could come in here and say, you know what? I don't want that to be there. So I'm going to say erase and fill. So I'm going to go ahead and say erase and fill. I only had to click on one face, and notice what it did. It actually fixed the part for me. You can kind of see the ghosted result, the original result in there. But we just removed that strut, if you want to call it that. And I could come in here and still make some changes. So for example, I could push this face in a little bit to kind of smooth things out so there wasn't that little nub or whatever right there. So you can kind of see how quickly I was able to resolve that particular area. I could also use just regular, selections. So for example, I'm just going to draw a box around this and hit the delete key on my keyboard, and it's going to delete that region. And now you see I got some weird holes here. I'm going to go ahead and just delete these individual faces that are kind of sticking out. And this is kind of the old method, and that's what I'm showing you. I really like that selection method where it finds that strut for me automatically. So I'm going to go ahead and delete these faces until I have just this little hole region right here. I'll come in and say fill hole. So I'll go ahead and click on all of these edges, and you can see how it filled that hole for me automatically. Okay, and again, I could come in here and tweak with this to my heart's content, pulling and scaling, etc., kind of changing what this looks like until I get a nice solution or whatever that I like. Okay. So you can kind of see how I was able to remove those arms. I won't do this one since we're kind of running short on time. The other thing is you'll notice that there's quite a few edges along here. And if we look at it, it's not too bad, but it can get kind of bumpy sometimes. So sometimes I might come in here and say, you know what, I don't want this line here. Maybe I'll get rid of this guy. Let's get rid of this guy, and finally maybe this guy. And I'm just going to hit the delete key on my keyboard, and Fusion's going to heal that, and you can see how we get a nice straight representation right there, instead of kind of this. It's a little bit hard to see, but it's a little bit warbly, if you want to call it that, right there. So again, I could come in and remove any of these. I'll leave maybe that one. Let's get rid of this guy here, that guy there. I'll hit delete, and it's going to smooth that region out for me automatically. Then when I'm all said and done, I'd hit finish form. Now I do have an opening there, so it might bark at me. But yeah, because it had the opening. So anyways, I just wanted to show you that even though you get this generative result, you do have the flexibility to come in and make changes and, you know, pull faces, remove edges, etc. Okay, we're at the top of the hour. I hope that this was a beneficial live stream for you. I mentioned at the beginning that because of Amazon Web Services and NVIDIA, you guys have access to generative design for free. So do some amazing stuff with it. You know, and we look forward to seeing you on a future live stream. Make sure you subscribe, hit the little bell icon if you haven't already. Thumbs up, thumbs down, whatever. We appreciate your feedback. If there's any other topics you'd like to see next year, please put those in the comments, and we will add those to our list. So again, with my dearest consent, I love the fact that you guys are enjoying these live streams, and I hope to see you in the near future. Thank you.